think we're starting, so thank you, everyone.
Get started.
Go ahead.
Yeah, sure. Cool. Well, thanks everyone for being here. People who chose to book their flights late and still show up in the lunch hour, thank you very much. Hope you like what you see here today. I'm Manu Bansal, one of the co-founders and CEO of Lightup Data. We solve the data quality problem, and I'm very excited to have Matt Sandler here with me today from McDonald's, who has been a long-time partner solving this problem with us at McDonald's for about 3 years now. Matt is one of the coolest execs I have ever worked with, and it's been a pleasure. He's just really made this such a fun project for the both of us. Matt has a really long career in data, building data platforms and data science technology on top at Apple and McKinsey, and he's been driving data products at McDonald's for the last 5 years. And very excited to have him tell his side of the story, and then I'll take some time at the end to tell you more about the Lightup platform and how we built it to be successful at the scale of McDonald's. Over to you, Matt. Thank you.
Thanks, Manu. Yeah, thank you all. I'm excited to share kind of our journey. So a few slides of background context. McDonald's. How many of you have eaten at McDonald's? Yep. I'll ask another question here. How many of you have a data quality platform now? Just one or two, just a few. All right. So background context at McDonald's, 40,000 restaurants, clearly, definitely the world's largest restaurant chain by a significant margin over our closest competitor. We're in 120 countries, and last year sales of all of our restaurants combined, $120 billion, so a massive operation. McDonald's, as many of you who may have seen the Founder movie, it's actually pretty good. It started in 1955 and has long been known for food, convenience, and value, and is regularly ranked as one of the most valuable brands in the world. But what's changing? What's changing is we're getting a lot of technology evolution going on. So we have mobile ordering and loyalty now. We have the kiosks in the stores. We have drive-through and digital menu board. We also have delivery, home delivery, both through the Uber Eats channel as well as our mobile app. I have a great little story to tell you about the kiosk, which is, I was at the airport about a few months ago, and there's a line 4 deep for the 2 kiosks at this restaurant, and there is no line at the front counter. Just all the people wanted to use the kiosk with no line at the front counter. So some of these digital products we've been launching are super popular. And with this change in how we show up for our customers, there's a big change in how we think about data and advanced analytics and what we're doing with it. So our data and analytics platform, we have, with roughly 40% of our sales in our top 6 markets now digital, we have about 12 petabytes of really actively used sort of tabular data. We have over 50,000 users using all of our writing SQL as well as utilizing all of our key data products, serving all parts of the company. And then in terms of how the platform works, at the highest level, we have the sources of transactional systems, like we've talked about, the point of sale, the mobile app, our supply chain systems. We have our core data platform and the usages. We'll go a little deeper on this here in a moment. So in terms of how the platform works, this is an inevitable simplification for any of you who worked at a Fortune 200 kind of company. We have all sorts of inputs, whether it's file-based, real-time flows, event streaming with managed Kafka. Then we landed at our data lake, do a lot of processing to get to clean, reliable, relational data that we expose through both Redshift and Databricks. We do compute with Python, some transient EMR, Lambda, and then Databricks has been a great partner both in terms of on the right-hand side with advanced analytics. Our data scientists get to use it, slice and dice, spin up clusters, look at data. And then in terms of our consumption, we have, of course, a lot of reporting, various BI tools, the self-service SQL, the data scientists, and then increasingly sophisticated AI machine learning capabilities, especially in areas like in our marketing areas, one of the ones we've gone deep on first. On the far right, some customer activation. And then some of the domains we serve across the top, and we're continuing to expand as we globalize our operations. So kind of gives you the rough idea. There's a lot going on. You can see Lightup there playing a key role, and we'll go a little deeper on that. By the way, at the end, we'll have time for about 10 minutes of questions. So if you have questions on any of these pieces as we go, please save them, and we'll come back. So what we're going to be covering is a little more of our data quality journey, how Lightup added value, what we're doing with all this better data quality, and then a little bit more on the Lightup platform for Manu. So why does data quality matter for McDonald's? Well, our business is all about growing a few percentage points per quarter, right? 3-4% a quarter is amazing, 1 to 2 is not so good. So what we find is even small errors in data quality, especially for new important initiatives, can swamp our ability to see what's going on in the business. So we launched a new program called Ready on Arrival. It's great. You can now order on the app and your food is actually ready right as you show up. And that starts as a small initiative, but we really need to see the growth rates on that to figure out how fast do we scale that across the country. And so these small errors can really have a profound impact on how we grow the business. The other thing is with our digital channels, and we'll come into this in a moment, like the way we use data is now much more transactional. 10, 15 years ago, if things are off by a percentage or two in certain reports, it doesn't really affect necessarily the macro level, depending on the decision. But now, if we have loyalty points not getting to us and giving you your loyalty points for a few stores out of 14,000, say in the US, that's a big deal. And so, poor data quality is really a hidden villain affecting all of our customer-facing operations, some of our supply chain, and increasingly our business performance all in. So more in the background context of our technology platform. So we have many complex flows and hands-off. Many big companies have this. We have a system that feeds data to the point of sale. It passes it to the server. It passes it to our data platform, which passes it to a marketing app, which then operates on it. So you could have 8 flows, 8 different sort of products, technology products. And each one, every 2 weeks, is releasing new things. It's really easy for hiccups to occur. And for a non-regulated entity, this has really been a challenge. How do you balance what's important? Additionally, we have variations because of how we grew up by point of sale, supply chain, mobile apps. And while we're globalizing and standardizing and we want to operate as one business, we definitely have a long way to go. And so this is sort of the background we're trying to solve for that motivates our data quality work. So as we really started to lean in on this about 3-4 years ago, this has been one of the most effective frameworks, actually, which is from a leadership point of view, which is the Swiss cheese model. And it's from safety engineering. You can wiki on this. It's pretty good. But it's all about when you have errors, how do you protect yourself from them getting through to affecting your operations? And for us, it's all about data quality. And some of the names of the layers across the top, we'll go a little deeper on 4 of them there in a slide. But what this captures is multiple layers are in action to address data reliability. And the reality of it is no layer is perfect. We have an outsourced workforce and parts. Things are constantly changing. It's hard to coordinate. Every layer has holes. And as a leadership team, whenever something gets through, we got to think, do we upgrade a layer to try to shrink the holes? Do we add a layer? Or can we streamline? Because we can't just keep adding process forever. So this has been really effective. For any of you who are working on the data quality problem at a leadership level, I highly recommend. This comes to mind often when we're making decisions about how to react to things. So 4 of these layers have been really valuable for us. One is these data contracts. So they're similar to an API between 2 systems, but they're a little broader. Sometimes you have file-based, and each data product and any upstream system are responsible for negotiating a signed-off contract that really details what they need to do between them. And as new features go live, these are evolving. The next piece to it is data monitoring, which is where we're going to go a little deeper on how Lightup has helped us. And I think of that as smoke detectors and then issue remediation. You really need teams, much like you have fire trucks. A smoke detector going off without a team to go address it is a big issue. And then that last layer, data error budgets. You may have heard of the term error budgets from Google. They've popularized that as part of their SRE work. We've been working on data error budgets for all of our data products. And that's really helped the product managers balance the tension between new features that they want to get out and where to harden the flows they currently have. So for us, again, as a non-regulated entity, and by regulated, I'm really thinking of banks, insurance companies, where the regulation really forces data quality and process to be a CEO-driven issue. We need to think of it more as what's important from a business point of view on many of these things. I want to say we're obviously very careful on things like SOX compliance and GDPR and CCPA, but when it comes to like anything outside of those core regulations, how do we balance what's important? This framework's been very valuable because depending on the evolution in the data product and the needs, this is adaptive to that area while still allowing us to have a leadership level or globally aligned way of working. And it creates clear accountability by product as they change. So we're going to spend most of the rest of the presentation going a little deeper on number 2 there, the data monitoring. Wanted to share this because what we're doing with data monitoring to be effective really fits into this broader framework. So a timeline, 2019, we really had no focus on data quality, lots of blame the upstream system. As we've added and grown the business relevance of our mobile app, our delivery, and especially loyalty, where loyalty points are like currency at a bank, we've got to get it right. We started to go deep on our first data quality and also added this framework. We started with an incumbent solution. I'll mention IDQ from Informatica. Definitely helped us get going. That said, it was difficult to build really advanced rules, and we needed a very large and centralized team to try to make it work. We started working with Lightup. And they've been very effective. We'll go a little deeper on some of the benefits here in the rest of the presentation, and we're continuing to expand, working now integrating with Data Catalog and some of the other features that Lightup's bringing. So how has Lightup added value for us? The Lightup launch, we started in 2021 with a handful of data quality checks. You can see the numbers there. And by 2022, it was really starting to work well. We started with anomaly detection and some things that the current platform couldn't do. We decided this is really ready for general launch. And we were able to actually port a year's worth of rules that we'd built in our other platform very quickly from Lightup. I think in a couple of weeks, we migrated a year's worth of checks. For those of you who have a platform, we continued to add. So by the end of 2022, we're at about 1,600 checks. And now, where are we today? We're at about 4,000 rules, 20 data products covered with monitoring. Each data product can own its own rules with very light support from a central team that manages the platform. We've got dashboards that enable data quality, and most of all, hundreds of potential data quality issues caught right away and addressed very quickly. So challenges the Lightup platform solved for us. To summarize, no specialized skills needed. With the prior tool, you really had to spend a lot of time in a custom interface. The vast majority of engineers, business analysts, and people from the business who are leaning in, they speak SQL. And that was really a key capability of Lightup, is they can prototype in SQL and directly push that down. That turns out to be harder than it looks, because if you do full scans over databases, they croak the database, and your DBAs will shut it down. So having Lightup support the ability to do just recency and held that as part of the platform was a huge value add. It's cloud native. It really works well with Redshift and Databricks. And then it works with our workflow. So the alert mechanisms can be integrated with Jira, ServiceNow, and others. Another example, so with 14,000 restaurants in the US, we needed kind of a model for each restaurant. In other tools, this was 14,000 data quality rules. In Lightup, it's one rule with a notion of slicing, and it does a lot of the anomaly detection for us automatically out of the box. Rule authoring went from about a month for one DQ check. So there's someone building it, someone validating it, someone testing it, someone deploying it. And now, certainly for many of the simpler checks, it can go to be prototyped and in production in 20 minutes. There's always, for very advanced checks, there's some discovery that's not included in that, but still a huge acceleration in the vast majority and much faster iteration and prototyping. We've been able to redeploy many people who are working on the centralized team to do other high-value things, and now all the different data products can have a much bigger part of owning their own journey with how data quality works for them. So that's kind of the high-level journey of data quality and how Lightup added value. A couple slides on what we're doing with all the better data quality. So we are upgrading our global supply chain forecasting, trying to integrate marketing with supply chain in ways we haven't been able to before. I mentioned ready on arrival, insights on how that's working. On the top right there, customer lifetime value is a big initiative for us, much more advanced segmentation models, and then of course, we're looking at Gen AI. So areas like crew training, ordering, and customer service are coming to the fore, and things that will really affect sort of our restaurant operations. All these things take really accurate data to really bring the value, and I would say 3-4 years ago when I first started at McDonald's, data quality came up a few times a month and it was an escalation. Why is this wrong? Why is that wrong? Now, silence is golden. I don't hear anything about data quality. In all honesty, I haven't had any issues with data quality coming to me as a senior leader in the team for months and months. It's fantastic. So the whole like PDR, those layers, and particularly the monitoring capability when you're in a data systems environment is a very hard problem. Lightup's been amazing. I've actually never had a tool deployed in my team that I've gotten more positive feedback from the working team on how well it works. So kudos to the Lightup team. One more slide here. So MarTech is a big area, marketing with our loyalty program. We're doing real-time activation, really more optimized offers, and upgrading our pricing engine capabilities. With real-time marketing, we have high-quality historical features that we calculate, and then we combine that with real-time clickstream information, and we've just launched our first abandoned cart, all with a level of quality and precision that we couldn't have before. So I think that's it from my part, and now Manu's going to take us through a little bit more on the Lightup platform.
Can you hear me fine? Yeah. Okay. Thanks, Matt. That was great. Always exciting to hear from a happy customer. Thanks for doing this. I'm curious, how many of you are putting data into production right now? All right. How many of you have written a data quality test yourself? Oh, amazing. I don't normally see that. That's very heartwarming to see. And any estimates on the amount of data that's going into production versus amount of data that's covered by data quality checks, right? So if 100% is, excuse me, data going into production, what fraction of that is actually covered by data quality tests today? Any volunteers? 5%. I have 5 going once, twice. How much? 5%? Okay. Any higher numbers out there? Nope. See, that's what we need to change, right? So when we started Lightup, we said, look, if software is going into production, the number you would not tolerate is 99%. You would want 100% coverage for software tests. We don't do that with data, but we're now putting data in the path of production, where it's driving customer experience directly, or it's responsible for some profile of the risk for the business. And yet, we are just putting that into production without any tests on it, right? So we said data is going to go prime time, right? And we've been hearing a lot about that in the summit and, of course, in the last few years, right? We saw data graduate from a nice luxury to being a necessity for BI to finally now directly affecting the top line or the bottom line for the business. And that's what data products are all about. If you're going to do that, you need data quality tests, right? I mean, you cannot fly blind. That's not a responsible way of putting data into production. But at the same time, the amount of data we're dealing with right now, it's a massive scaling problem just to build out and deploy those data quality tests. And so that's where we are stuck right now. We know we need to write those tests, but we don't have the tools right now because the scale we are dealing with, the last generation of tools simply doesn't work. So I'm curious, those of you who have written data quality tests, any samples on how long does it take you to go from concept to production for one simple test? Are we talking minutes? Are we talking days, weeks, months? Like, what does it take you to go build out a data quality test in production? Any volunteers? Who is under a day? Who is over a week? So go ask your teams, right? The estimates we see very frequently are anywhere between 4 to 8 weeks, right? And I mean, it looks ugly for a reason. I'm not going to read through all the steps that need to happen to build out a data quality test in production. But when you're really trying to solve this problem at scale, You have to first prototype the test where you discover your data, you arrive at a specification where the product managers, especially for the data team, would give you a spec. The engineers try and understand what is good data, what is bad data. You would spend some time profiling that data and discovering your own requirements, maybe figuring out where the thresholds should be. Go around, build some prototypes in SQL. All right, that takes a couple of weeks worth of exercise. You have a prototype at this point which works on a sample of data. It's not yet ready to be put into production because it's not going to scale, not as it stands. So now you move to the next phase where it goes to a data engineering team to build out, where the SQL, excuse me, this dirty SQL implementation will now get converted to a Spark job built in Scala or Java, and a lot gets lost in translation. And now, by the end of the scalable implementation, turns out it's not actually doing what it's supposed to do. And so now you go back and you have this really long feedback loop, right? And when everything is said and done, now you still have the job of stitching this up into your workflow so that you can start to get alerts on it, you can make it actionable, you can file tickets out of it, and you can put a process around who triages and manages those incidents and is responsible for seeing them through, right? And in that process, you might detect even more issues with your data quality criteria because you never really got to backtest it, right? And so now you're just waiting and watching how this performs. First few weeks, it's not actually useful, it's very noisy, you go back to the drawing board. And so that's why we are at the scenario where we are, where 5% is the coverage number or 10% the best I've ever heard, right? It's just too slow to build those checks out at scale. And so what we have been able to do is cut this down to minutes in most cases. That's what you need. If this is really going to go prime time, this is going to go at scale, that's what you actually need, right? Now, how did we do this, right? So let's talk about that. So when we said we wanted to solve the data quality problem at scale, we said, look, we don't want to limit you in your ability to build out these deep, complex checks, which are often very business specific. You should still be able to build out a check that models your business, your applications, and aligns to your data model. You want to put data from 14,000 restaurants in one table, that's fine. You want to create 14,000 different tables, one for each restaurant, that's fine too. We would build a system in a way so that you can still write all your complex checks with all the business criteria on any of those data models. In any of those cases, the check will still scale. We wanted an environment where what you prototype is your implementation. There's just never any rewriting that needs to happen. And when you are playing with the definition and you arrive at something you are satisfied with, that implementation is now going to also work for petabytes of data or 1 billion rows a day. So you need that. And then last but not the least, this might in fact be the most critical design principle, you need this to be so easy so that this is no longer an expert task. If it's an expert task, it starts to bottleneck on a data engineering team, it doesn't scale. Right? Data engineers are very precious resources as it stands. And if they are spending half their time building those tests out, that's a massive waste. Right? You need this so that this can go all the way to line of business users. Not only is that more scalable, but that kind of democratizes building those data quality checks out to the people who are closest to the business value of data. If I'm putting this data into production and I'm a business user, I understand best what's good data versus what bad data. Right? I have my own criteria. The engineer sitting deep in the platform doesn't really appreciate where to draw the line. And you don't want to over-engineer. So who can make that call best? The one who is actually using this data. So then how did we architect the platform? The platform is built to support scale, of course, ease of use, and still be a complete end-to-end platform where there's no additional engineering needed to put this into operations. So it's a layered system with the core of it being what we call DQIs, data quality indicators. So the thought process here is, a typical monitoring system will have metrics, monitors, and incidents. What's the analog of that for the data stack? Right? We talk about KPIs, we talk about metrics on the observability side for the IT stack. What's the equivalent for data quality? Well, data quality indicators. You want to track number of transactions coming in from a McDonald's restaurant into the Redshift cluster? Well, that's a DQI. You're just describing the count as a function of time, that's your metric, right? So there's those DQIs, which are often pre-built and reusable, but then you can customize them to your will, specific to the business, by writing full SQL. Now, on top of that is a layer of anomaly detection where you're not sitting and trying to calibrate bounds on those DQIs by hand. You can just point the system to the last 3 weeks of data or last 3 years and tell it to learn the pattern of what looks good versus what's bad. Right? So that, again, takes out a massive time sink where you're just having to calibrate those rules. And then the third component here is an incident management workflow, which really makes us an operational system. So data quality traditionally has been an analytical need, where the end target is a data steward, a human being who is expected to run a report interactively and then stare at those results. This is different. This is operational. Like Matt said, right? I mean, it's lights out monitoring. If everything is running fine, you don't want to even look at this system. We'll flag you if something goes bad, and that means that there needs to be a full workflow around it. So that's how the system is built. Now, the core of the system is the data quality indicators, and that's where we see a lot of systems fail, where they're not scalable, and that's where we changed the most in how we architect the system. So let's look at how we built DQIs for scale. Let's go back to what the traditional architecture looks like, right? Without naming any names, traditional platforms were built for a scenario where you had data living on spreadsheets or data sitting in CSV files, where you didn't really have a compute engine where the data resided. So what you had to do in that case was to import this data into the DQ tool first before you could test it. Now, it was all well and good when the data volumes were low. Now, this started to evolve into an architecture when data volume scaled, which is the DQ tool will now embed a big data compute engine. For example, it would just spin up its own Spark cluster. Sounds good in theory. Turns out it's really hard to make this work in practice. It just creates a whole new DevOps problem just to manage the DQ system. And by moving data now from where it already lives, which might in fact be a Spark cluster to begin with, or a Databricks cluster, you are basically causing the user to remodel the data and start from scratch. And you may have introduced artifacts that were artificial because you went from one system which had good data and maybe it got broken in the path from moving into the data quality tool. So now you're detecting just an artificial issue. So you don't want to do that. Now, the other competing architecture we are seeing is a metadata architecture that tries to get around the scalability problem by instead invoking metadata instead of trying to scan the actual data. Now, that's good for basic checks like, did this table update in the last hour or so? But if you're trying to run a test where you want to catch a $5,000 transaction at a McDonald's restaurant, well, that almost never happens. I have not seen a trailer full of burgers being taken out, right? Typical value is $50 for this transaction. There's no way you're going to be able to answer that question by only looking at metadata. You have to scan the actual data itself, right? So you get scalability at the compromise of the depth of checks you can run. So what we were able to accomplish was the best of both worlds, where we said, look, you have to scan the data. There's no shortcut here. But we're not going to move data either. We're going to push queries down into Databricks or Snowflake or Redshift, wherever the data lives, so that the data quality's big data compute will happen as part of your platform. That works beautifully, right? And there's a lot of detail here that I'm not getting into, but Matt referred to some of that, where we never do full table scans, even though we have to scan data. It's always incremental computation, where you're only looking at new data. So that's how we make it efficient, right? So that's the secret sauce behind DQIs becoming scalable. And then we have designed the system to serve 3 different personas who we very frequently see coming together to implement data quality in practice. So that's your business users, who usually don't want to write code, sometimes not even SQL. They can just write their own checks through a drop-down interface. There are data analysts for whom the language of choice is SQL. And then there are developers who are willing to write code and do much more powerful operations, right? So if you're an analyst, you can just pick out a check from a pre-canned menu of checks that are already available in the platform, configure a few properties about the data model, about the business, turn them on, toggle them on, off you go, right? If you are an analyst and your favorite language is SQL, you can customize the checks to your heart's will and Lightup still makes it very easy for this SQL check to be an incremental computation instead of a full table scan. So a lot goes into writing SQL but still being able to run check-pointed computation, because you basically have to now remember the last time you ran this check, and it quickly becomes a state management problem from a software point of view. All that is taken care of, but you can still write SQL in the native dialect of the data platform, whether it's Databricks or Redshift or Snowflake. And last but not the least, if you're a programmer trying to stitch this up into your pipeline, maybe you want to build out data quality checks programmatically, you want to trigger them through an Airflow job, or maybe you want to export or import results into another BI tool, you could do all of that too. There is an API interface, and you could just even potentially write inline checks where those checks would run as part of your data pipeline, right? So really, it's serving all those three groups who usually have slightly different requirements. The anomaly detection layer is architected also very uniquely. So this has been our experience working with a lot of anomaly detection systems which would come in and try to be the magician or the oracle, where they will come in and claim, hey, you don't need to tell me anything about your data, I'll just start detecting issues. Right? So that kind of autopilot model we haven't really seen work very well in practice. Instead, what works a lot better is the copilot way of doing this, where the end user will still need to provide some input, like train this on the last 3 weeks of data, because last 3 weeks were good, but leave out maybe the second week because that's when things were broken. Right? So that kind of intuitive input where the user is coming in and giving you very weak labels in a language that's very intuitive to a business user. So that gives us the right balance between being able to control the model, but still not needing to be a data scientist and conveniently deploying an anomaly detection model as a non-expert. There's a lot more that goes into this to make this really work accurately at scale, being able to backtest what you built, being able to calibrate this and say, hey, this is being too sensitive, let's make it a little less sensitive, or let's make it a bit more sensitive, right? But all simple knobs that are very easy for you and me to understand. And the third component is the operational angle of this platform, where this is kind of batteries included. You just get into Jira or ServiceNow, PagerDuty out of the box, no programming to do, it just fits in your stack. Right? So that's what the platform looks like. There's a lot more behind it. One thing that has always also been a design principle, especially working with large organizations like McDonald's with a lot of data sensitivity, is we have architected this platform to be very portable. It's not built for one specific cloud or one specific environment. It's completely agnostic, which means you can deploy it in your cloud of choice. You can deploy it on-prem. You could deploy it in a hybrid model. You could have this connect to both kinds of properties. And you can put this in a very regulated setting too if you're a HIPAA compliant customer or serving banking standards. So that's what I wanted to talk to you about today. There's a couple of ways to engage with us if you like what you're seeing here. You can just go to our website right now, grab a Docker instance, and start to play with this on your own. You can also find us on Databricks Partner Connect. So if you're a Databricks customer, there's a Partner Connect portal. You'll find a Lightup tile. You click that, it spins up a Lightup SaaS instance that directly connects to your Databricks cluster. And of course, we have a booth here, so please feel free to stop by, discuss more, grab a sheet, whatnot, and we'd be happy to set up a conversation with you. So that's all I have, and we have about 5 minutes for Q&A. So I would love to take questions, as would Matt. Thank you.